Okay, I am from Ferrero Academy. This is my lecture. Today's lecture is on physics. It's for SI units. Uh, SI units. Actually, every physical quantity requires a unit. Now, every physical quantity requires a unit. Now, but there are some fundamental or base physical quantities. First, I will define what the fundamental or base physical quantity. Fundamental or base physical quantity. Fundamental or base physical quantity is that which is very difficult to define, which is very difficult, to define. Okay, you have a concept, but it's very difficult. To define. Fundamental physical quantity is that which is very difficult to define. For example, time. You cannot define time. You have a concept. But you cannot make understand some other person what the time. But you can understand yourself what the time. So time is a base or fundamental quantity. Similarly, we cannot define length. Length is, suppose if you want to define length, you have a concept, but you cannot define it. You cannot tell any other body what the length is. But everybody has the concept of the length. So these are some fundamental or base quantities. Okay. Now in this first lecture, actually is I will tell you what the SI units are for, and this is the fundamental quantity. Other ones are the derived quantities. What are the derived physical quantities? Derived physical quantities are those which depend upon the fundamental physical quantities. So similarly for SI units, SI units have been assigned to base physical quantities known as base SI units. Other ones are known as derived SI units, and third ones are known as which also the part and parcel of this SI units are the prefixes. So SI units, when we say SI units, it consists of mainly three things: base SI units, derived SI units, and prefixes. Okay, let us see what are those base SI units. Actually, there are 7 base quantities defined in physics. But actually 5 are in A-levels course, and the one is in A2's course, but 5, you can say 6 are in A-levels course, but 7th, which is the luminance index, is not in A-levels course, but you can write it. So we have the base SI quantities like this one. I can make a table like this one. This is the base or fundamental physical quantity. Its notation, then base SI unit, then its symbol. So this is a small table. It will consist of 7 columns, 7 quantities: base or fundamental physical quantity, notation, base SI unit, symbol. Now actually it needs these notation of the base or fundamental quantity must be standardized. They are not standardized because there are so many notations for one physical one notation for so many physical quantities. For example, you have a momentum. P is denoted by linear momentum is denoted by P. Similarly, power is denoted by P. Pressure is denoted by P. So many quantities. Time is denoted by T. Temperature is also denoted by T. So actually we have to, scientists have to work to standardize the notation of physical quantity. That's a need of hour. But base SI units have been standardized. The symbols for the base SI units have been standardized. First is the length. Length is denoted by L, small l, capital L, D, S, X, Y, etc. So many other things which denotes the length. So length, then its base SI unit is meter. Its spelling is METRE because we are studying just the UK's syllabus. Cambridge or others, but they accept the meter is METRE spelling and its symbol is M. So the first physical fundamental unit is its length and its unit is meter and its M. Then the mass of the body, its M or M, its unit is kilogram, its symbol is kg. Here K is in lowercase. K is in lowercase. Keep in mind, K is in lowercase here. Actually, that's the one exception where we have taken the standard prefix has been taken with the standard. Kilo is the very prefix. I will discuss prefix in one of the lectures separately here after these lectures. So it's a kilogram. Then it's the time. Time is written by T capital, T small, also T small, and its unit is second. It's small s. Please care must be taken while writing the units of second. It must be small s because capital S is used for another unit which is for the which is Simon, which is the unit of electrical quantity, conductance or conduct. So we will not discuss it here, but it must be small s. Then the current, small I, capital I, its unit is ampere. Please, when we write a unit in words, it must be with the small letter, because if you write a capital word ampere, capital A, it becomes the name of the scientist. Actually, the unit is after his name. So ampere is a unit, letter must not be capitalized. So ampere is ampere, but symbol is capital A. Actually, when there are the symbols of the names of some scientists, they are usually capitalized, and the first letter is capitalized and the second is usually lowercase. There is an exception for one unit I will tell you here in this lecture today. Current, then there is the amount, first the temperature. Temperature, it's small t, capital T. Its unit is Kelvin. It is capital K. Okay, K is capital. Temperature, then it is the amount of substance. It's done by small n. It's SI unit small. Its symbol is MOL. These all units, actually 1, 2, 3, these 5 units are in AS level course, and this amount of substance is in A2 level course, and this another course, this another physical quantity is luminous intensity. It is denoted by I, phi. Its base SI unit is candela, and here's an exception. Here's an exception. Here C and D both are in lowercase. So these are actually the 7 fundamental quantities and its units. So this is the SI base units. There are 1, 2, 3, 7 base quantities. Base quantity or base physical quantity is that which cannot be defined or which is very difficult to define. And there are so many notations. Notations have not been standardized. These are the names and these are the symbols. First is the length. Length is a SI base unit meter. Its symbol is M. Mass, capital M and M is notated kilogram, and it's kg. K and G are together. K is a small. Then time, small t, capital is second. It's small, it's not capital S, as I told you already. It's for the Simons. Then current is I, and capital I, it's ampere in A. Capital symbol, temperature T, capital T, and Kelvin, capital K. Similarly, amount of substance is small n or mole, MOL, symbol is mole. Luminous intensity is I or phi, it's a candela or CT. So this is all about the base SI units. The second part will be for the drive SI units.